Hello, this is the third part of our mHM videos. Here we were seeing the test basin input folder, lat_long files, length use, length cover files, only ASCII files, and gauges, the gauge of stream flow measurements, and meteorological files, and netcdf format, morphologic files, aspect, them all mostly created from DM, aspect, flow accumulation, flow direction, and slope all comes from DM. Soil classes, geology classes, and your ID gauges all are here. And optional data we don't need right now. And here we have our executable. If you double click, the model will run, but when it finished, it will close. So the best way is, after you define the CYGWIN bin folder, you can just use command prompt to run your model. What we were doing, this one. Let's try direct mHM. It's not recognized. Therefore, we need to define where is this file. Okay, see, mHM finished. And these are the performance of the models for Basin 1 and Basin 2. All right, let's study a little bit the model files. Operations are mainly made by these three name lists. It's a convention for Fortran models, name list, NML. This is a parameter file, mHM parameter.nml, lower upper boundary, and the current value of the 53, 56 parameters. It's a distributed model, and output resolutions and output fluxes can be turn on or turn off. This is the switch. If you want daily outputs, you say -1 here. And then if you don't want interceptional storage written to the output file, you can close them by false. Whatever you are interested in these outputs, there are quite a range of variables that can be retrieved after the model simulation. I'm running now monthly scale, okay, and then this is the main GU of the model. This is the main operation room. Number of basins, the hydrologic scale, routing scale, and time step of the model. If you want to optimize, you make through this one. You select one of these options. Now it is DDS, and then you can select one of the objective functions predefined, and the folders that's required to run a model. Currently, it is directing to the test basin 1 and 2. Now it's a pre-cooked, well-running model. The processes are here. These two we added to the model. Now it is fed as equation, and this is what we added, -1. Currently it is an aspect driving correction. This is quite a straightforward model. The simulation period 1990 for the test basin 1 to 1993, so 3-year simulation. 0 warming days for test basin 1, 180 days for test basin 2. So you need to study this file before running. Our mission is to show you the basics of the model. So you can either double click, or you can shift right click, open PowerShell, and then write mHM. That's it. If you want to prepare your own model, just copy these files and then prepare exactly similar structure, and it will be fine. And the results are also interesting. The discharge out observed, simulated the date information. You can plot it in Excel file, and it's also available in netcdf format.